Hey everyone, so now we're going to be talking about arithmetic series. So arithmetic series are slightly different than arithmetic sequences. While they're the same, like we're adding something every time, in series there's an ending to them. So in an arithmetic sequence, remember we had those dots to them, so they went on forever and ever. In an arithmetic series, you have an ending. There's only so many terms, and so you can actually sum up the series or add all of these terms together and find the total amount of each series. So the way that we can do that is with two different formulas. The first formula is on the top of my page, which is S sub n is equal to n times a1 plus an all divided by 2. Where a1 is your first term, an is your last term, and then n is the number of terms. And then, or you can use the second equation, which is S sub n is equal to n times 2 times a1 plus d times n minus 1, all divided by 2. Once again, n is the number of terms you have, a1 is your first term, d is the common difference that we talked about in the last video, so that's what you're adding or subtracting every time. And so we can use either of these formulas. Both of them will work. And it just depends on what you're given in the equation or in the question to decide which one we use. So let's start with the first example. The first example gives us that a1, which is our first term, is 22. an, which is the last term, is 78. And then n is equal to 8. So potentially, we could try and figure out all of those numbers. We know the first number is 22, the last number is 78. We know that we're adding, or we know that there's 8 terms, so we could figure out what we're adding every time and then write out all the numbers and add them all up together to find the sum. But it's going to be way easier than that because we can actually just use that top equation because we have all of that information. So I'm going to use the top equation, which is S sub n is equal to n times a1 plus an over 2, which when I plug in what I know, the n is going to be 8, a1 is 22, an is 78. Then we're going to divide that by 2, and now I can just plug that into a calculator, which would give me 400. So I know that the sum of all of the numbers would be 400. Okay, let's try another example. And in this example, we're given something slightly different. So we're given the start of the series. And notice that instead of commas, we have plus signs in between them, and that's because we know we're going to add them all together. And even though there's that dot, they tell us that there are 7 terms with that n equals 7. So potentially, we already have 4 terms. Potentially, I could figure out what we're adding every time, which I'm going to do that anyway, and then write out those last 3 terms and add them together. That would make sense and that would work. But we're going to use one of these formulas just so I can show you how to use it. So, for that first equation that we had, we needed the first and the last term. But for the second example, we don't have the last term. So we're going to end up having to use the second equation, this one right here. We know the n and we have the first term, which is 16, just that first number. The thing that we need to have is the d, the common difference. So that's what we're going to try and figure out now, what we're adding every time. So from 16 to 23, we add 7. From 23 to 30, we add 7. From 30 to 37, we add 7. So that means that d has to be equal to 7. So now we should have everything in order to use that bottom equation. So let me just rewrite it out. And all right. And let's start replacing. So we would have n, which they told us is 7, 2 times your first term. The first term is just that first number, which is 16, plus d. We just decided that's 7. That's what we're adding every time. And then n again, so 7 minus 1, all divided by 2. Oh, and I'm a dum-dum and just wrote n right there, but we know that n is 7, so I'm going to replace that with a 7. Okay, so now I can plug that into a calculator, and I would get 259. So my sum, if I added all of those numbers together, if I had 7 numbers and I added them all together, I'd have the sum would be 259. And we use S sub n to say sum, just because S starts with, like, sum starts with S. And that just shows we're finding the sum, not a specific term. Okay, let's do another example like that. So this next example is -43 plus -53. And we know that n is equal to 16. So once again, we could continue to write this out until you have 16 numbers, but we're going to use the formula. And this is really similar to that second example where you have the first term and you know the number of terms. So you have a1 and n, you just don't have the d. So first we're going to find d. When I go from -43 to -53, I'm losing, or I'm subtracting, and I'm going to subtract 10. So each time we're subtracting 10, which means that my d is -10. Okay, now we're going to use that same formula as before. So what I'm going to do is just, let's see if we can cut it and paste it so that we can use it down here. Okay, so then for my n, we know that's 16. They told us that. 2 times your a1, which is -43, plus your d is what you're adding or subtracting every time, so that's -10, and then n minus 1, so 16 minus 1. That's all over 2. Now let's plug that in to the calculator. And I get that the sum, if I added all those together, I would get -1888. 1,888. So if I add all of those numbers together, I'd get a big negative number. That makes sense because all of those numbers are negative. So when I add a bunch of negative numbers up together, I should get a really big negative number. All right, one more example. So in this example, you have this big E looking thing, and that's called a sigma. Sigma is a Greek letter that stands for sum in math. And so the way that we read this is the formula is 8k minus 8, and we want to figure out if I plug in 1 for k and then get an answer, and then plug in 2 for k and get an answer, plug in 3 for k and get an answer, all the way up until I plug in 12 for k and get an answer, and then add all of those answers together, what would I get? And so there's a function on your calculator that will do this for you, but I'm going to show you how to do this with a formula. The formula that we're going to use on here is the one that's S sub n is equal to n times a1 plus an over 2. So in order for that to work, we need the n, the a1, and the an. So the n is actually pretty easy to find on the sigma. The n will always be the top number. So I know that n is equal to 12 in this case. Now we need to find a1 and an. Now, to find those, they're actually pretty easy. Well, for a1, that just tells me what I'm going to do is take that equation, the 8k minus 8, and replace the k with 1. So I'm going to say 8, but instead of k, I'm going to put a 1 minus 8 and figure out what that is. So 8 times 1 is 8, minus 8 gives me 0. So a sub 1 is 0. And then to find a sub n, if I know that n is 12, then that's, oh, sorry guys. Oh my goodness. One sec. There we go. If I know that n is 12, then an is the same thing as saying a sub 12, which is the same thing as replacing the k with a 12. So I'm going to have 8 times 12 minus 8, which is 88. Okay, so now I have everything that I need for this equation. So I'm going to say S sub n is equal to n, which we decided was 12, times a1, which is 0, plus an, which is 88, all divided by 2. Now I can just plug that into a calculator, and I would get 528. So my sum is 528. And there you have it, how to find sums of arithmetic series.